Good morning. Welcome back. Today's topic is conductors and dielectrics. In the last video lecture, we have discussed about determining the electric field intensity and electric static potential due to a dipole. And also, we have also developed expressions for torque, which is experienced by a dipole when it is placed in an electric field. In today's video lecture, I hope that by the end of today's video lecture, you will understand what are the behaviors of conducting and dielectric materials and why they are so important for us in our electrical engineering. Coming to the start, we'll go back to the chemistry where we know that any atom basically consists of a nucleus, which is positively charged, which consists of protons and neutrons, and it is basically positively charged and very heavy weight when compared to the electrons, which are of light weight, and they will be revolving around the nucleus in certain orbits. Now, depending upon the availability of electrons, you know that in some materials, these electrons they will be available freely in nature, which means that they will be developing some crystal lattice-like structure where these electrons they will be flowing freely in the lattice structure, or what we can say is nothing but they will be loosely bound by the nucleus. So for easy understanding, I'll write them as easily detachable from the nucleus. Or you may find some materials where the electrons are not that much easily detachable from the nucleus. So what method you are employing for detaching these electrons from nucleus, it depends upon the circumstance or the scenario. Now in this context, I'll be using, let us suppose we do employ electric fields. If on the application of electric fields, if the electrons are easily detachable from the nucleus, from the atom, then these are called as conductor materials. Whereas if they are not that much easy to get detached, these will be called as insulator materials. In these insulator materials, the electrons will be very rigidly bounded to the nucleus. So a normal electric field will not be able to detach them. But on the application of higher electric fields, they may get detached. And that scenario is called as breakdown. But let us confine ourselves only to basic things of conductors and insulators. So our next question immediately arises: what is the difference between an insulator and a dielectric? An insulator and dielectric, most of the times in electrical engineering, these words are used interchangeably. But the major difference is that whenever you are using any electric field, whenever you are applying any electric field, what happens is that a conductor basically, if it is a conductor material, let us suppose I am applying some sort of electric field here. So I am applying an electric field. If I place a conductor material here, then automatically the conductor may release electrons, which will flow due to the effect of this electric field. But whereas in insulators, the insulators are normally bound to stop the flow of current. So they won't release electrons under normal conditions, and these electrons are strongly bound towards the nucleus. So externally appearing, there won't be any release of electrons. So no release of electrons under normal conditions. Now the question is that even though there is no release of electrons, but there may be an appearance of small types of charges which do appear in the molecule or an atom. So what happens is that if I apply this electric field, normally let us suppose if this is an atom and this is a nucleus and these are electrons, let us suppose. So when this electric field is applied, so what happens is, let us suppose the field is like this. What happens is that these electrons, they may, or whatever the negative charges are there, they make it attracted a little bit towards the positively side, whereas the nucleus make it a little bit shifted towards the negative side, which means that physically the electrons are not coming out of the atom, but they are dislocated from their initial position. This mechanism is called as polarization, where the electrons are not coming out, but they are developing a little bit charges on the two ends of your atom. So the developing of charges and then reorienting it in the direction of electric field, this process is called as polarization. So somehow all the materials basically they exhibit polarization. In fact, all of the insulating materials, when they are subjected to electric field, they may not release electrons under normal conditions, but they will develop some sort of poles, what we call them as atomic dipole, and these atomic dipoles may reorient in the direction of electric fields. This context of using some sort of energy which cannot be regained back, this concept is called as polarization, where internally poles have been developed and reorientation has been occurred. And this extent of polarization, it varies with materials. So since there is an impact of electric field on the materials, on the insulating materials, these are called as dielectric materials. If there is no impact of electric field, then it may not be a dielectric material. But 99.99% so far, which I do believe, all the insulating materials are somehow they have this impact of electric field, and so they are termed as dielectric materials. So I would like to clear one. A dielectric material is necessarily, so if you take insulating materials like this, the dielectric materials will be like this. Dielectric materials are basically subset of insulating materials. All dielectric materials are necessarily insulating materials, but I cannot say that all insulating materials are dielectric materials. But since most of the insulating materials are dielectric materials, when we talk about the electrical engineering, we discuss about dielectric materials only. Okay, so this is the concept of polarization. Now the major difference between this dielectric and conductor is that a dielectric is basically an insulator, so it won't allow the current to flow through it, whereas a conductor which allows the current to flow through it. In a dielectric material, the electric field direction will be surface, parallel to the surface, where it will be perpendicular to the surface. Whereas in a dielectric, it will be present inside the material because you are developing some sort of dipole, so field will be developed inside. But whereas in conductors, there won't be any field, there will be directly movement of electrons. And dielectric substances do not contain any free charge carriers. Only conductors do present these electrons, which will be traversing from one position to another position due to the application of electric fields. And next is the temperature effect on conductivity. As already said, the conductivity will be very minimum here, whereas it will be very maximum. They are bound to be conductive in nature, conductors. And this conductivity decreases with temperature, whereas here it will be very minimum under normal conditions, which will increase with temperature. So that's what I have said. Bulk conductivity is small, whereas here it is large, and it will be decreasing with temperature, whereas it will be increasing with temperature. And coming to polarization, here electric polarization happens. Here it won't happen for normal frequencies and also for higher frequencies also. But in case of very high frequencies, then there may be a chance of polarization. And coming to the examples, these are commonly used dielectric materials in our electrical engineering. This is the most strongest one, and this is the most cheapest one, and these are commonly found in our day-to-day life. Whereas conductors, this is the highest conductive material, followed by this, and this is the followed by this. And this is also a metal which is extensively used for conduction purposes. Having said this, we will move on to types of dielectric materials. When we move on to types of dielectric materials, I'll confine myself to say when we go with the compounds, there may be different types of compounds, right? You may experience ionic compounds and also covalent compounds. Normally, ionic compounds are conductors in nature, whereas covalent compounds, they exhibit dielectric properties. And you know that there are two different types of these covalent bonds, what we call them as polar and also non-polar. Polar means non-homogeneous materials, whereas non-polar means they can be of homogeneous type. So in polar dielectrics, what happens is the molecules they form dipoles even in the absence of electric field. Say you take water. Water will be having defaultly H plus and OH minus. So when I take a cup of water, normally these H plus and OH minus, they will be oriented in this in different fashion. See, the net impact of this electric field will be 0. See, the net charge on this entire substance will be 0. But if I start applying the electric field in this fashion, then automatically what happens is, let us suppose if I start applying the electric fields, then automatically these dipoles, they will orient themselves in the direction of the applied electric field. See what happens is, this is OH minus and this is H plus. See, all these, they will be oriented in this fashion. Okay. So even in the absence of electric field, the dipoles are disposed at random. The resultant electric field is 0. But on the application of electric field, these dipoles, they rearrange themselves so that their axes are aligned with the applied fields. So this electric field, it orients the positive charges in the direction of electric fields, and negative charges will be oriented in the opposite direction. And this shifting, it results in an instantaneous current, what we call it as displacement currents. Because initially this is like this, now there is a shifting of position, which means the charges are shifting a little bit. Since the charges are moving, it is considered to be a current, right? So that current is called as displacement current. It will be only for a fraction of seconds, and it will be only a small amount of current. But that fraction of seconds current and that small current, it is considerable in some cases, what we call it as displacement current. Now coming to non-polar dielectric materials, normally what happens is, in these dielectrics, the positive and negative elements, they are very close to each other such that their action is neutral. They don't have any external charges on them. But on the application of electric field, the positive and negative charges may be appearing a little bit by leading it to a dipole. See, these type of carbon compounds, methane, benzene, etc., they may exhibit a little bit charges when you apply electric field on them. These are called as non-polar dielectrics. So, having said this, now I hope that you are able to understand what is the concept of conducting material and dielectric material, and what is the difference between a dielectric material and an insulating material. Thank you, and I hope that you will be able to answer this particular question. How do dielectric materials behave when they are subject to electric fields? Thank you. We'll meet in the next lecture to discuss about in detail the concept of polarization and how it is measured.